Hi and welcome to this video in the MRDCL Understanding Concept series. And in this video we're going to be looking at getting the size of files and checking for the presence of files so you can implement automation. So what does that all mean? Because it's a very long title. I think the longest title we've got for any video. Well, what it means is that what we want to do here is we're going to look at files, see what's in those files, so that we can respond to that in the script, so that parts of code, for example, are automatically executed and implemented. So let's bring that to life a little, because we've got 4 or 5 examples here that will make that clear what I'm talking about, and also give you some ideas of how you can use this automation technique. So I'm going to start by looking at the data files. If we open up the files here, you'll see there's 2 data files, Asia.ask and Europe.ask. Let's open the Asia one first. So if we look at this, you can see in the first 3 fields, I have a record number. So we've got 501, 502, 503, and 504. In the next field, I've got the continent. So all of the Asia ones have a 2 here. The next field is for gender, and the next field here is for age. And then we've got 5 fields which represent the presence of 5 brands. So one means that they are aware of a brand maybe, or it's brand A has been chosen. The next field will be brand B, brand C, brand B, D, and brand E. And finally, we've got a 2-digit number on the end here as well that's being collected. I'm only telling you this just so that when you see the script in a minute, it'll make a little bit more sense. So if we just jump to the European file, it looks pretty much the same. This time we've got 3 records and the structure of the data is the same. You'll see there's a 1 in that full field for each record because Europe's been coded as 1, unlike the 2 in the Asia file. But otherwise, they're exactly the same in their data structures. All right, so let's look at the script here and just see what is going on in this script and how we're going to use these automation features and looking at the size of files. Now, if we come down the script, you can see it's all pretty straightforward script. There's a C equals here telling it to read the European data and the Asian data. And then those definitions that I sort of talked about just now. Continent is 4, 1 to 2. Europe, Asia, then gender, 5, 1 to 2, age, and then that multi, the brands, Q1 in 7 to 11. And then you'll see there's an extra question in here which wasn't in the data, and indeed if we look at that, you'll see it's actually got a dummy definition with 7 empty codes in it. Now what I'm going to use that for is for backcoding, so that what I can do, I can have a spreadsheet or a CSV file in this particular case, so that based on the record number, I can backcode data to those 7 responses. And we'll come to that in just a moment. So that's question 2. You can see here I've got some code for banners. And now you can see the first of these automation files. Now the first thing I've got here is a file called starlines Europe equals Europe.ask. So what that's going to do, into the index Europe, I could call it any name I wanted to, into the index Europe, I'm counting the number of lines of in Europe.asc. So we saw 3 records just now. So the index Europe will take a value of 3, whereas the index Asia will take a value of 4, because you may recall that had 4 lines in it. And we'll come back to using that in just a little while as well. Now here you can see I'm looking at a file called coding.csv. I'm asking MRDCL to tell me in coding rows how many lines there are in coding.csv. And here's the files in that folder. And if we look at coding.csv, the file I was just referring to in that script, you can see that it's made up of just 8 rows, a header row in the top row. The record numbers, you may recall the European records were 1, 2, and 3. The Asian records were 501, 502, 503, and some answers that we want to backcode for that question 2 variable that you may remember, which was just defined as an empty variable. There's a different number of answers, as you can see, for each respondent. So let's go back to our script now, have a look at that. So this is going to, first of all, count the number of rows in coding.csv and storing that in coding rows. Now what it's doing now, it's saying, well, if there is no file called coding.csv, that will have set the value of coding rows to null so that we can just skip to 99 if the file doesn't exist. Now this is very much with automation in mind. What you could do is if that file coding.csv is not present, it wouldn't try and do anything here, and it would skip our code. So it would just jump over that if the file didn't exist. Now that just means you could use this sort of technique from project to project so that it didn't, if the file wasn't there, it didn't try to do any of the back coding, whereas if the file is there, it implements the back coding. So let's look at the script that's going to automate the back coding for us. So having jumped over it, if it's not there, well, we just saw it was there, so we're okay. The next thing I'm doing is putting that into a data statement. So this is rather like a data statement, except it's coming straight from the CSV file. So rather than the data statement being made up of a list within the script, this time it's going to read it across here. So the first item in the data statement will be this. That'll be the second, third, fourth, fifth, sixth, seventh. The 8th statement will be this one, the 9th, right through to the final statement in the bottom right-hand corner where I'm highlighting now. So that's going to put it into a data statement. It's the same as having a data statement. You'll note the syntax that is needed. Then you can see I've got a set command here, and in that index called coding cells, it's counting the number of items in coding sheet. So again, if we go back to this, it's 8 rows by 7 columns, so it's going to return a value of 56 for that for me. So coding cells will take a value of 56. And then to get the number of columns, I'm saying the number of columns, so I'm going to set coding cols to be coding cells, which we know is 56, divided by the coding rows, which is 8, so it will give me the value of 7. So by just having those simple commands there, we've managed to store within our script that this particular spreadsheet's got 8 rows, 7 columns, and 56 cells in total. Now what that means is if more lines or more columns, in either rows or columns, get added to that CSV file, my script will work perfectly well. So once it's set up, that spreadsheet, there's no need to change the layout of the layout or the code within the CSV file. So if we were to add a 505 in here with some more codes, or we were to add over here answers 7 and 8, or take 2 of these columns out, everything would work because the script here is doing all the counting and all the arithmetic to know how many rows and columns there are. Now we can say what I want to do is loop round from coding cols +1. Now I don't want to process the header row because that's got, if you like, invalid characters. I want to start one line below. So if we look at coding cols again, that cell there would be the 7th column. This will be the 8th cell because, as I showed just now, it wraps around. So it's going to start at the 8th cell. It's going to carry on in that do loop until the final cell, but it's going to go up in steps of 7 because we now know there's 7 columns in this spreadsheet. And as I said, if we added answer 7 and answer 8, it would make it 2 more. Now we've got the code that says if the serial number is the field in coding sheet.a, so if it's that particular cell, make question 2 blank dot, and now we can pick up the code. So I'm first of all reading the code into here, and I'm saying if there's no code in there, I don't want to put a code. I don't want to output a code because I don't want to put out dot blank. That would make invalid MRDCL script. And I want to loop round all those answers until I get to the end for as many that have got answers. Now, I won't go through all that code in detail there because we're actually getting into sort of basic preprocessor code here. Let's look at what output we get. And if we go down to the listing file, it now looks perfectly good. It says if IOBS is 1, make Q2 B.1.2.3. If it's 2, 1, 3, 5, 7, and so on. So you can see that it's actually generating exactly the script we want for our back coding. All right, so let's now take a look at the rest of this script. Back to the script, let's see what else is going on here. And we've got a similar principle going on here. We're saying that check the number of lines in data corrections.stp. If it doesn't exist, jump that insert file and insert that file if it does exist. So again, to bring that to life, we've got a file here called data corrections, and it's got one line of code in it, and it's putting one false in on the data. And again, you see, you could make that a generic piece of script that you do on every project. So if your scripts find a file called data corrections.stp, it implements it. If there are no data corrections, it just ignores it and just carries on. Now let's look at another thing that we can do, where we can look at files and respond according to the contents of that particular file. So here we go again. We're now going to open up, this time, a spreadsheet. So I'm now setting a reference to open the spreadsheet, and the spreadsheet's called spreadsheet.xlsx. Let's take a look at that. And the contents of that sheet are very simple. A column with code in it, a column with brand in it, and there's 10 rows of data in here with a header in it yet again. Let's close that. So how can we automate here? So here, DB lines is counting the number of lines, so brand counts being set to the number of lines in the workbook called spreadsheet.xls and the worksheet called brands. Now, rather than using star lines, we're using star DB lines because it's an Excel, or it could be an Access table, but this is an Excel worksheet in this case. So once we know that, we can set a loop, and we can pick up all the codes in that spreadsheet using standard EPS script. If you're not familiar with EPS, I suggest you watch the EPS videos to introduce you to that. But what it means now is I can loop round, and what I'm heading for here is I want to skip over the semicolon when I get to the last brand, because as you may know, in MRDCL syntax, you need to end on quote comma. So what I'm saying is, well, I've got no brand so far. Let's loop round that worksheet. Each time I find one, let's go up by one. And that means then when I get to the final brand, if got is the same as the actual number of brands that we counted back here, I can skip over that semicolon and my code will work perfectly well. All right, so we've seen various bits of script there. Now let's see some of these in action. So let's go back to that coding example first of all and just run that. Look at the results, and if we go down to question 2, you can see there's all my back coding working. And just to test how that works, if the file isn't there, I'm going to briefly rename this file with an X on the front. Now coding.csv doesn't exist. So if I run it now, we should drop from 5 pages to 4 pages because that table is empty. And indeed it is. We go table 1, Q1, and we jump straight to table 2, which is not question 2 anymore. So that appears to be working quite well. So we've done some automation with our coding. There we go. Let's set it back so that table will now reappear. Let's now look at other things that we've run here. So let's see what else is automated. We can see our brands coming out nicely here now. And if we look at the listing file and look at the script that produced there, you can see that Q3 that picked up that 2-digit brand has dropped out all the codes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And here it's missed the quote comma. It's missed the semicolon and gone straight to the quote comma. Now let's look at how we can use this in tables, just to take this one step further. So we come to tables, and you can see here that's the code that was skipping the table for Q2 if there's no coding rows. We've got a similar thing here. There's a table here that's filtered on Europe and a table filtered on Asia. So if we go back to our tables and scroll down, you can see there's the table for Europe, there's the table for Asia. And now let's look what happens if we get rid of the Asia data. Let's put an X on the front of that. Edit the script here just so that Asia's no longer present, and run it again. And we've now hopefully lost the table that was for Asia. There's the brands, there's the Europe sample table, and the Asia one's disappeared because there is no Asian data. Well, I hope that's been useful to you to learn some things about how you can look for the presence of files, test how many rows, columns, and cells there are in sheets so that you can process code accordingly. It really does improve your automation and allows you to set up some systems that you can use from project to project automatically. So thank you for joining me. I hope it's been useful to you.